Yeah, I think um I will try to maybe summarize what we learned today. So can everyone see the slides for this one? Okay, yeah. Um I think right now I will try to quickly summarize what we have learned. So first, 에너지부터 what we haven't covered today really was energy. So you still remember what energy is? So yeah, energy is the ability to do work. So energy causes change all around us. And the sun is the Earth's main source of energy for life on Earth. And there is also the concept called energy transfer, in which energy moves from one object to another. And energy cannot be created or destroyed. And this concept is called the law of conservation of energy. But overall, energy is what makes things work, what makes things happen, right? And today we covered these two types of energy, the kinetic and the potential energy. But there are other types of energy like thermal or heat energy, things like chemical energy too, things like electrical energy, nuclear energy, radiant energy, and sound energy, things like that. And here are just some examples of how energy can be transformed. It can turn from electrical energy into sound and light energy. It can turn from chemical energy, like our food, to mechanical energy, like how we move. And there are many other types of transformation. So that is energy. So remember, the unit of energy is joule. Like you said, 1 joule is the energy used when a force of 1 Newton moves an object 1 meter. So it's when you apply 1 Newton in the same direction in 1 meter, and you would get the total energy in that direction of 1 joule. So we already did this question. Um, Remember that joule is always a capital letter, J. So that is why the answer for this question is A, because all the other answers don't fully say joule. Like this J is lowercase, and this letter is also lowercase. So that is not the standard unit for energy. But you guys got it correct. So, great job on that. So this was the basic SI units. Um, if you had a question about this, here are the examples. So there are meter for length, Kelvin K for temperature. There is ampere or A for electric current. Second is the standard unit for time. And there are other things like kilograms for mass and mole for amount of substance. And here are, like, they have talked about the derived units, and these are separate units that are derived from the SI units. It's a combination. It's not standard, but it can be useful. Things like finding the area, or finding the volume, or finding the density, speed, acceleration, all of these require derived units. And things like force and energy too. So let's review once again about potential and kinetic energy. So potential energy is the stored energy based on its position, right? We already talked about this. So the kinetic energy is the energy of an object due to its motion. So there is always a change occurring from potential to kinetic. But remember, the law of conservation of energy states that no energy can be created or destroyed. So it's just being transformed from potential to kinetic. There is no energy loss. So, for example, if this girl drops the ball from a cliff, then the potential energy from the ball transforms into kinetic energy as it falls down. Yeah, potential energy is the stored energy. We already talked about this, but it's based on the position. So for gravitational potential energy, it's based on height, how high the object is. For elastic potential energy, it also depends on position, but this is in terms of how much the spring is compressed or stretched from its neutral state. So for gravitational potential energy, the higher you go, the more potential energy you have. And this is just talking about gravity. Like gravity is the force that pulls objects towards each other. And here, yeah, we talked about gravitational potential energy and this equation right here. Just remember this equation that is used to find the potential energy due to gravity, and that is mgh. Remember? M is the mass of the object. G is the gravitational constant acceleration, which is always 10. So you can replace G by 10. And then H is the height, the position of the object. This is really important, really, really important when solving questions like in the DECE exam. So just remember, potential energy, mass times 10, gravitational constant times height. Okay, great. So, yeah, we already solved this problem, but revisiting, you can see that potential energy is mgh. So m is 2 kilograms for this question. And then g is 10. And height is also 10. See here, it says 10 meters tall. So that's why 2 times 10 times 10 is 200. Yeah, is everything clear so far? Do you have a question about energy? Um, no question about energy, then I think we can move on. Um, yeah, we already looked at this question, but all of these similarly involve potential energy equals mgh.
200 times 10. And you realize times 10, which is 1,000 and 2,000.
Yeah, that's right. Potential energy is mass times gravitational constant times height. So let's look at another type of energy. Remember the kinetic energy. So what is kinetic energy? So kinetic energy is the energy an object possesses due to its motion. So it's also called an energy of motion. So all moving objects have kinetic energy. So this is the equation of kinetic energy, this one. So it is 1/2 time
Like
mass times velocity squared. So remember this equation for kinetic energy. This will be useful when solving questions.
Okay.
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 Okay, yeah. So let's look at the next slide. We also talked about velocity, right? So velocity is the speed of an object in a specific direction. And velocity has both magnitude and direction. So you might be confused when I said a vector quantity, but that just means that velocity has both magnitude and direction. So speed, it's different from speed in a sense that velocity has a direction. So let's say you are walking to the right. You're walking to the right at 5 meters per second. So 5 meters per second is the speed, but velocity is strictly saying 5 meters per second to the right. So it has a direction. But you can simply calculate the velocity by distance over time. So velocity is distance over time. Yes, distance over time is yeah, that's right. S is distance. So here we put S as displacement and T is time. So
Why is so John and did you
yeah, that's right. And the unit, remember, is meters per second is the unit. And you can convert it to something else like kilometers per hour or even miles per hour. Yeah, so this is velocity. Yeah. And this is acceleration. So acceleration is the rate at which an object's velocity change. So A, acceleration is v over t. So yeah, A v over t. Yeah, thank you. But acceleration is the change of velocity. So it's v over t. That's how you find acceleration.
Acceleration is
No. This is what أنا بعمل
acceleration.
already بشر.
Yes. Velocity divided by time. Yes.
By the way, أنا
Mass times volume times time.
U. Mass potential is mass times kinetic. Mass times velocity. Velocity. Velocity squared.
Yes. So velocity, remember, is distance over time, but acceleration is velocity over time. Okay. Yeah, does that make sense for everyone? Okay. So we have an example here. So this person moves 30 meters in 5 seconds. What is the velocity? So can everyone answer this question? Yeah.
This meters per second.
This is
This means this minutes.
Oh, yes, that is
First,
correct. So it's 6 meters per second. Remember, the unit for velocity is meter per second, meter divided by second. So that's right. So it's 6 meters per second. What about acceleration on the right? Here,
fire.
speed for the first instance is 30 meters per second. And then it speeds up to 35 meters per second. And change of time is 10 seconds. So what is the acceleration of the car?
1.5 meters seconds per second.
But dancing, I make dance.
No, this one this
풀고 있어야지. 아니 없어. 내가 하면 한 번 더 하고 있어. 내가 다시 설명해주고 있어.
Okay.
12.5 meters per second square.
Yeah, that's right. So it is 0.5 meters per second squared because
Wait.
the change of speed, change of velocity is 35 minus 5 equals 30. Sorry, it's 5 meters per second minus 30 equals 5 meters per second. So that is the velocity, the change of velocity. And it's over time. So 5 divided by time, which is 10 seconds, equals 0.5 meters per second squared. Yeah, that's great. That's the unit for acceleration.
Just can you wait?
So velocity and speed is how fast the car is. So velocity means how fast an object is moving, and acceleration is how fast the velocity changes. Did everyone understand velocity and acceleration?
Yes.
Okay,
Yes.
great. I'm going to just skip over some questions because you already did them. Finally, I want to talk about work and force, and we can end today after this. So, do you remember what force is? So, force is a push or a pull that changes an object's motion or shape.
Times. Last time.
Yes. So, force is the capacity to do work, and force causes movement. Force causes movement. And force is found by multiplying mass by acceleration. So remember this equation. Force equals mass times acceleration. F equals ma. That's how
Okay.
you find force. Okay, yeah. M is mass, A is acceleration, and the unit is in newtons. Yes, okay.
Yes.
Okay. And yeah, we talked about a lot of different forces. Here are just some examples of a lot of types of forces. Because we also talked about gravitational force today. So that is just one type of force that is acting on objects. But there are a lot of different forces in the universe. Okay, let's move on. We already did this. The force that makes a mango fall from a tree is
Yes.
gravitational force. This will be, yeah, the gravitational force because gravity pulls things down. There is gravitational force acting down to the mango. So remember that gravity is the force of attraction between two objects. So the Earth is pulling us down by the force of gravity. Think. So here we are finding both the acceleration and the force. So acceleration, we already found this. So we have acceleration. Remember the equation? V over t, right? And this is the change of the change of velocity over change of time. So remember, it is 150 minus 100 because we end with 150 and we start with 100. Add over t is 10 seconds from the question. So we have 50 over 10. And what is this? This is 5 meters per second squared. Yeah, I hope this makes sense for acceleration and finding acceleration. And the force, according to this, let's find the force. F equals ma. Remember this. So F equals acceleration. We found the acceleration to be 5. And the mass is 1,000. So 1,000 kilograms times 5. And what is this? This is 5,000 newtons. Yeah, does everyone understand how to find acceleration and force? Do you have any questions?
Baby, yeah, nice for you. Assimilation.
똑똑이
네.
명이서 그거 같이 얘기하고 서로 앤서 얘기하고 있어. Okay. So, do you understand how to solve this problem?
Yes, understand well.
Okay, yeah, great.
Please, can you wait a minute so that we can copy it?
Okay, you can copy. I will write down again. B over T, equals.
Let me tell you. Yeah. Five.
You can tell me if you are finished writing down, but I can also send you the slides after class so you can copy it too.
Okay.
Wala watu nasi hapa online.
Are you ready to move on or should I wait a little?
Please, we are done copying it.
Okay, yeah. I will move on then. So, yeah, I think we answered this question already. The force meter measures the weight, right? Because weight is force. So weight is the only force option that is on the option. So mass is not a force. Temperature is not a force. And work is not a force, but it can be derived from it. But it's not a force. Weight is the only force. That's why the answer is C for this question. Okay. And work, let's talk about work. So work is done when a force moves an object in the direction of the force. So work is FD, force times distance. And the unit is in joules. So work happens only when force moves an object. If the object doesn't move, there is no work. So if you lift a box, work is done because force is applied up and the box also moves up. But pushing a wall, there is no work because the wall doesn't move. So, okay. I think this picture will be clear. So, if this person moves the box 2 meters, then work is done. Work is force times distance. So he applies 10 Newton force by 2 meters. So 10 times 2 is 20. So 20 joules of work is done. But the one on the bottom, this person, he does 0 work because there is no change of distance. Distance is 0, so work is 0.
Okay.
Okay.
Good answer.
No time.
If there is no movement of an object, there is no work. Okay, so let's look at this question.
Right.
A machine lifts a load of 100 Newton through a vertical distance of 2 meters in 10 seconds. What is the work done by the machine?
C. What? C.
Oh, yes, that is right. If you answered C, because work is force times distance is 100 times 2 multiplied by 2 equals 200 joules. So that is why the answer is C. Yeah, great job. It's 200. Okay. Yeah. Work is just force times distance. So let's look at this other question. The work done by force of 20 Newton on a body is 60 joules. It says to calculate the distance which the force moved. We can find the distance by rearranging this equation of work is force times distance.
A.
So,
A.
the answer for this is not A actually. Because let's look at this question. Work is 60 joules. So work is given to be 60. And force is 20. And we want to know the distance. So 20 times what is 60? In other words,
C.
oh yeah, I think I heard C, that is correct. So 60 over 20 is 3. 3 meters. That's why the answer is C, 3 meters. Yeah, great job. I think the last couple of slides is about inclined planes. So we will finish with this. So inclined plane is a simple machine consisting of tilted surface that allows a force to be applied over a longer distance to lift or lower a heavy load, thus requiring less input force than lifting it vertically. So we use inclined planes to reduce force. If you have ever pulled a cart over a hill, a steep hill like this one requires you to pull stronger with more force. But if there is a less steep hill, you would require less force to cover the distance. So finally, let's look at this question and end for today. So, okay. So given that 1 is 400 Newton and it moves a distance of 10 meters. So what is the work done by the person? So distance is 10. Remember, work is force times distance.
100 times 10
Times
times 10.
100
It's 4,000 joules.
Yes, that's right. It's 4,000. Great job.
times 500.
Force is
The
400.
second is 500 joules.
Yeah, the distance is 10.
500 joules.
Oh, yeah, for the second one, it's 500 because the force of the box, it's given to be 100 newtons.
Okay.
So the weight is 100 newtons.
2.5.
And the object moves up 5 meters. So that is why
12.5 joules.
500.
12.5 joules.
Yeah, if you're talking about the efficiency, yeah,
Yes.
then it is 12.5% because the efficiency is work output over work input. So 500 over 4,000 is 12.5%. So yeah, that's how you would answer this question. Yeah, do you feel confident answering this question if it was on the test?
Yes.
Okay. Yeah, great job for today. Do you have any other questions before we end today?
Okay.
Yeah, this will be the last chance to ask questions if you have. But great job, everyone, for following along and understanding the topic. It can be a little confusing, but I hope you were able to learn something for today.
Yes.
Okay, great. Um, yeah, do you not have any questions for today?
Any other question? All right. So they have no other question for today.
Yeah, thank you so much for
Is that the
listening.
end?
I know today was a little long, but we will have class next week too. And
Yes, next.
yes, that's right. And next week we will cover Newton's laws and solar system.
Let's go. The Newton's laws, right?
Yes, that's right. And the solar
Okay.
system. Yeah.
All right.
Okay.
Okay. So next week we will be treating what the Newton's law. Yes. All right.
Yeah, and solar system. That's correct. Okay. Yeah, I will share you the slides and you can look at it after if you want to.
Okay. All right. All right.
All right, sounds good. Yeah. Then, yeah, I'll see everyone next week. Bye, everyone. Bye. Okay.
Okay.